welcome to the third part of how to write an operator from scratch. Today we're going to be covering observability, and as part of that we're going to be looking at traces, logs, metrics, and if we have time at the end we'll get on to the Dockerization and deployment of our operator into a cluster. So without any further ado, let's look at where we are. We effectively wrote a simple operator called cn-skunkworks operator. This operator has two different subscription mechanisms. It has a config map subscription, and it has a pod subscription. And the idea here is that we have a set of annotations that we want to write out to every pod in the cluster in a specific namespace or cluster-wide. And the reason for this is the real-world example of potentially a CNI or a CSI that requires an annotation to know whether or not a pod should have network capabilities or storage capabilities added into it. So these are kind of our examples of where this might be useful in real life. So if we actually dive into the code quickly, let's have a quick recap on how this operates. Now, if I start it up, we'll see that we have the two subscription mechanisms. Those operate through the primary run loop, and you can see here that we've got a bunch of added events that have come through for recent operations in the cluster. I'm running a simple kind cluster in Docker locally, and that kind cluster is what I'm using to test my operator by connecting directly to it through the kubeconfig. So what are the next steps? Well, the operator itself has no real observability. We built a very simple method for handling the Prometheus HTTP requests, and let's go revisit that. Apart from that, we've not done much else. We've imported klog, and we've used a bit of logging output. So let's focus on metrics first. This HTTP handler for metrics effectively allows us on the default port to get metrics coming from Golang from the runtime. So this will be memstats, this will be garbage collection, this will be things like the go routine count as well. And it's pretty useful, but at the same time, we want to build some specific metrics in for our use case. So somewhere we can start is by understanding the packages of Prometheus. So PromHTTP is a sub-package that provides us the handler. We've also got Prometheus as a top-level package and PromAuto. And PromAuto is a package that returns structures that represent one of the four primary types in Prometheus. So as a refresher, that's gauge, counter, histogram, and summary. So let's say that we want to have a metric to display when the operator has an available platform config. So the way I would probably go about doing this is to create a gauge. And the gauge can be at 1 or at 0, right? So let's call this Prometheus platform config availability gauge. And from here we can use PromAuto. And PromAuto, you see you've got a whole bunch of stuff you can do. So you've got a new gauge that we want to create. Now we could create a gauge function or a vector or just a new gauge. We can create a new gauge vector, and I'll show you why that's interesting in a moment. So here this takes Prometheus.gaugeOptions, and gaugeOptions also has an array of labels. And this is particularly useful if you want to add additional information into that gauge other than being up or down. So for example, we could add pod name and namespace. And the gauge options themselves, we've got to explain a little bit about what it does. So if we look into gauge options, you've got name, namespace, and a few other bits and pieces that we can control. So let's set the name. Prometheus, so we're going to call that platform config availability gauge. In fact, I'll call it, just to keep these things concise, we'll call it cn-skunkworks, in fact, skunkworks platform config availability, just because grouping in Prometheus is quite important and it's a useful thing to employ. So that's unused at the moment, and that's absolutely fine. So let's grab this gauge, and where would we implement it? Well, when we add a new platform config map and grab that data out, we know that that's available. When we delete it, we know it's been destroyed. So let's try that. So what we want to do is we want to call that variable, and we want to call the with label values parameter, and then we can set that to float 64 of 1. Now, the important part here is with the label values. So with the label values are going to be the additional values we're adding on as labels. So in this case, we're using the pod namespace. So if we scroll up, and I'm sorry, it's not pod name, it's going to be config map name. So we use the config map name, which we have from the reconcile object. So config map name and config map namespace. And what's interesting here is that, as you can see, you can start to add a lot of these values. Now, it's just important to remember that these will have a direct correlation with the number of time series that get created within Prometheus. So for now, we'll add a 1 on a new creation and a 0 on the deletion. So let's see if that works. So if I go down to main.go, we start debugging. I've got an instance already running, so let me just reboot it. And once that gets up and running, if I refresh this now, we should see that we get a new metric. So if I go type in CN skunkworks, so I don't see it yet. That's not a problem, I'm not too worried. Let's go have a look and make sure that we've done everything correctly here. Okay, so if we go to the top, we've got the new gauge vector. We're setting that through prom auto. We refresh. And if I scroll down, I think I called it platform config. I might need to add some additional options in here, so let's see what else we need. So we haven't got a help string. So I'll add the help string in as well. This tells us whether a platform config is available. Okay. And with that, let's just make sure that the logic makes sense. So have we seen an added event or a deletion event? So last video, I was talking about an interesting place where in this particular pattern that we built on this operator, if something exists prior to the operator seeing any kind of CRUD, we have no way of detecting it. And that's something that we'll follow up on with notifiers and with watchers. But at the moment, we're relying on being told, is this being created? Is this being deleted? Because prior to seeing that, we won't see any events from that config map because we don't have a loop running inside of this struct independently to constantly check or poll, which we can do later on if we would like to have a look at that. And what I mean by this is if I go to K9s right now and we click into the config maps that are running, we'll see here that we have no platform config. And so therefore you would expect that to be a 0, right? But there hasn't been a deletion event. So we'll only see if there's a deletion event. So what I'll do, just to exemplify this, so if I go examples, platform config, and we create that, you'll see that we get that config map added, and therefore now what we'll see is our CN skunkworks platform config availability has just popped up. And so Prometheus doesn't know about the metrics prior to that, so therefore wouldn't know to say if it's missing. Equally, if I now go and delete it, and I'll just remove this auto suggestion at the end here. And I delete that, we'll see that it's gone back to 0. So that works. I mentioned briefly, how would you resolve this? Well, you can have an independent loop inside of your operator that is constantly monitoring config maps for this. Or what is probably more ideal is for those complex scenarios, we would actually use an exporter that would monitor this completely independently. So I hope that makes clear the outline of how you would add a simple metric. Just to really drive that home, let's do a second metric, which will be kind of contrived, but it might be useful just for really exemplifying how this works. So we're going to call this Prometheus platform config annotation count. And this annotation count, even though it says it's a count, it will still be a gauge because the counter in Prometheus only goes up, whereas the gauge can be set to go low again. So in this particular example, I'll use again promauto.newGauge. I don't have to make it a vector gauge. It doesn't need to have the additional labels this time. So let's go prometheus.gaugeOps. Again, in here, we'll add a name, CN skunkworks, platform, config, annotation count. And this tells us within the config map. Okay, great. And again, it's a pretty simple thing to implement. Down here, we set that gauge, and that gauge can be set to float 64 of the length of p dot platform config dot annotations. And then again, we would zero it out on a deletion. Let's try that again. So we should see there's nothing to start with. The count is 0. Let's create that config map, refresh, and you can see that we have an annotation count of 2 now because we have the SRE annotation and we also have the annotation for owner type as well. So that's great, this works. This is how you can implement simple metrics. These can be then scraped from Prometheus, and we'll get towards that later on in the video. So metrics are super important to add because they can give us alerting data. They can give us very early warnings on, is the operator experiencing any problems? Is it noticing any changes in the system? And we can measure this empirically through here. The next thing I want to highlight at a quick surface level is the way that we use structured logging. So Klog is a very simple logging tool, but if we want to go down the route of having slightly more sophisticated logging, we can remove Klog and we can implement something like Logross. Now, Logross is a really interesting tool because of the way that you can apply fields and have pre-annotated fields that you can pull into the current logger. So I'm just going to grab Logross, and if I then pull that into my project, I'm doing a lot of this from memory, so we'll see how that goes. Now I think it might actually be using a lowercase s. There we go. So let's switch from using Klog to using Logross. So I'm going to get rid of Klog. I'm going to replace all of the instances with it. And we'll take it a little bit further as well. Any example of logging, we will simply replace within our code. We'll get rid of Klog. And replace with Logross. Okay. There we go. Now, another really important part of Logross to get the most out of it is to set it up properly. So in our init function, as good a place as any, is we can set up Logross. Now, I recommend probably going to the docs on this for some examples. But what is really powerful, as I said, is the with fields component. So I'm going to do two things. When we set the formatter up, I'm going to make sure that we're switching the formatter to JSON. And then I'm also going to make sure that the log level is set to debug. So we've got JSON formatter, and this is on the global Logross object. And we'll set it to debug. So let's just go ahead and rebuild our operator. First thing we've got to do is to run the import again properly. There's a different version. Let's go ahead and start debugging. And already you can see that a few things look different and a few things look the same. One of which is that the log messages are coming out as structured JSON here, but they aren't here. So let's go down and have a look at why these ones aren't. So that's inside of the pod subscription. And that is because it's using the info F on here, I believe. So we can switch this to use our info object, and we'll pass it a pre-formatted line we can also do a few other things. Now, as you can see here, Logross is really powerful because you have this log with fields option. So what I could do on this reconcile to make it a bit more interesting is to not just tell us the subscription event of the pod, I could also give information like the namespace that is also being utilized. So let's look at how we would do that. So you would call log.withFields, and this field data, you would then populate a log fields object. And in here we could say something like namespace, and that would be the pod.namespace. And then we would then call the command of info. And that then moves down to here. And this is a super simple example of how you can start to add structured logging into your code. What's interesting as well is that when we think about things like Loki, we can think about these structured fields as being things that are being pulled out later on. That is super, super useful for us to be able to investigate and to look at. And you can see now that the namespace of kube system has been appended to each one of these log messages here, which is really, really interesting and really nice to see. So let's go back to our main here. And what's interesting is that we can see with very little code, we've implemented metrics that are useful. We now are on the way to having structured logging because now we can search by level info, especially if we're using Splunk or Loki or some other solution. But what about tracing? And often I think folks get a bit scared of implementing JaegerTracing. And let's remember what we're actually doing here. So we're exposing metrics to Prometheus. We're also emitting logs to the standard out to be scraped by Promtail or FluentBit or some other log collection service. And we also want to directly send traces somewhere, right? And these traces provide us very precise and high fidelity understanding of what's going on in our code. So the way I would do this is typically look at the open tracing documentation. It's really, really straightforward. So let's pick up getting started with Jaeger, for example. It describes here, get the Jaeger all in one. We can do this. Let's just spin this up in our terminal. I might even have it running. Nope, there we go. So Jaeger's now running locally. Let's find the Golang example. And it looks scary, but it's really not. So let's tidy this up a bit. Metrics, tracing, and I'll move the logs initialization code into the same place, just so it's all concise. So we've copied in Jaeger, and already we've got a bunch of errors coming through. But again, we need to just grab the imports, pop these imports in, and let's figure out what does and what doesn't work. So Jaeger looks like it's undeclared. So I'm going to go off into the terminal quickly and grab all of these imports that are required. Okay, so we've got our imports, and Jaeger has suddenly fallen quiet again. Let's look at actually what it's doing here. So this is the config for tracing. So we're setting constant sample rate. Now there are a few different types of sample rate. Constant means that it's going to be sampling on a one-to-one. So every request that goes through sampling code will get a sample. So a trace with spans will be emitted. You have adaptive sampling as well, which allows you to send, say, 1 in 10, 1 in 50. And that's a really useful spectrum, because that can then give you the ability to lower the frequency if you're flooding the remote sampling server endpoint. And again, it's important to understand that there's also a combination of agent-side sampling and remote server-side sampling. We also have the reporter config set up here, which comes as default. And the reporter config is part of this object that allows you to see in the CLI the spans that are being created. And that's quite convenient when you want to copy a span out and look at it in Jaeger in the browser. So just to remind you what Jaeger is, if I go to my browser here, this is coming from that Docker container. Jaeger gives us a beautiful little UX that hopefully we can see some stuff coming out of our operator in a moment as we start to send traces to it. So let's follow the guide. Next thing we've got to do is now we've got our config new, we probably want to put our cn skunkworks operator in as the name for the service that's being sent. And again here, what it's doing is sending up a global tracer. And that global tracer is accessible anywhere within the project. The one thing we will look at later on is at the moment we're passing in the Jaeger standard logger, which is fine, but it is possible to modify the Logross logger interface to pass into Jaeger instead, just so we're not using multiple different types of logging components throughout our code. So let's just give this a restart. Oh, before we do, we can see that there's a naming conflict. Config and config between Jaeger and between Kubernetes aren't happy, so we'll just change this to kubeconfig here. And we will then rename this down here. Let's give that a play and see what happens. And hopefully that will run pretty straightforward. Yeah, so Jaeger started, no problems whatsoever. We're not really capturing any spans as of yet. That's Jaeger query's self-monitoring system, and you can see that Jaeger is aware that there have been API calls for registration. Now that we've done that, this is where the fun part comes in. So let's go to config map and actually annotate some of the reconcile loop. So you can see here there's an example. What we do is we call the global tracing context at the top of our function, and every time we want to create a subspan, we would call it from the parent. So let's call this the root span, and when the root span finishes on the defer, it will close. Now, before we get that far, let's just make sure we can take the open tracing import, pop it in there. Is platform config map. That is an opportunity to surround this inside of a child span. So what we could do is we could position it so that we have root span. In fact, that's the wrong around. We'd say is platform config span, and we go open tracing dot global tracer start span is platform config span, and then we put the open tracing child of, and then it becomes root span here, and then that has the context passed to it like that, and then we can defer is platform config span finish. And what probably makes sense at this point would be to think about where this is going to be. So really, we could pass the trace context into this function to make it a bit more accurate, because otherwise it becomes tricky. If we exit out, we want to defer the close. If we continue, we also want to close. So we could pass it in, and to pass that in, the actual object that's going through there is this span type. So we can have a look at passing that span type, and we can decide if it looks right. So what I'm talking about is to change that to something like this. I'm putting the defer the finish here. So however this exits, and that root span context then becomes root span, and that config map here needs to be adjusted so that root span can be passed in. We also see an interesting error occurring, so let's have a look. Mixed name and unnamed parameters, that's because I've put root span in like this, which is an open tracing span type. That goes into here, and when it comes out again, it adds on. So the difficulty here, just to play devil's advocate, is that because I've added that span here, how do I then connect to more subspans? And this is the question of, okay, well, do you actually go inside the function to do it? So if we think about what I'm talking about here, right? So let's say that we have 3 layers of spans. So we have a function that calls a function that calls a function, right? And that's the root. And we're actually passing through the root to that function. How do we get to this third function? In the current model, there is no return. It's not returning the is platform config span. So it kind of dies here and comes back up. Therefore, you're then having to start this span from the root context again, which will look incorrect in Jaeger, because it will look as if they're in parallel, but actually it's a child of. So what we want to do is to sequence it like this. So what you can do is, like we had here, is be clever around where you put the defer finish. And so again, I tend to like thinking of these things as what was the last action it was doing, and when you think about it in that context rather than where it should go, that is where it starts to become a lot easier to work with. So this is the current activity, right? If it fails, it'll hit the error, and if it hits that error, it returns. If it returns, it hits defer here, it hits defer here, and the trace then bubbles up. That's fine. Then what we can say is, specifically, if it goes into one of these, we can add a span context around here. When that completes, it bubbles back up. Now again, just to show you how this works, we would take the is platform config span, and we place a new span here. We could say watch event add, watch event add, and that is a child context of is platform config span, and we would then complete this span here. We can also do that inside of the deleted span, because these are alternative paths on the tree, and that also needs is platform config, and we can call it on the modified. So I've talked a lot there. Let's start looking at what this actually means. So now I've brought up Jaeger in the local Docker container just for clarity, and we can see that we have our events. And what's really cool about this is that our traces are starting to send, and you can see the is platform config. Now what I would like to do is actually show you what does one of these completed traces look like. So let's do a keep control delete. I think we're in a place we can do examples. Run a deletion operation. Let's go back. Let's search for samples. We can see we have 3 spans here, and we've got our watch deleted event. And that was done with a few lines of code inside of the config map subscription here, where we start with our top level root span and go down, and it's calling the deletion code here. And this is extremely useful because we can start to monitor latency. In addition to this, we can add tags, and one of the big underutilized feature of Jaeger is that we can have baggage. Baggage items are a way to carry across additional key value pairs of information that we can look at for additional debugging information and diagnostics. For example, you can add a label onto a Jaeger span, and you can add baggage on top of that, both of which will help you when you're building operators and diagnosing them. So yeah, in a nutshell, that is how you add JaegerTracing. We can extend that as much as we like. We can put that on multiple reconciliation loops as well, so that on pod events we can do something similar, again taking the reconcile as the top level with the root span. So we could call this the config map subscription reconcile, and we'll do something similar for the pod subscription reconcile just here. Again, importing open tracing, and we have again these very simple operations that we can add a subspan to down here. I'll just grab one and recycle it, and we can use the root span here and here and here. And this will give us a high level of fidelity over our operators' processes as they're running asynchronously. And this is really, really important, especially as complexity starts to increase within your operator. And you can see here our reconciliation loops. And again, here is the pod subscription for the watch event add. So we've covered how to add metrics. We've covered how to structure logs using libraries such as Logross and using with formatter fields. And we've looked briefly at how to implement JaegerTracing. The interesting part to me now is how do we put that all together, package this operator up into something that's consumable? Well, Firstly, we need to write a very simple Docker file. I've just taken one from a previous project of mine. This one here pulls the latest Golang, creates a directory, it adds our current files into that directory, it then does a build, and then the output for us would be cn skunkworks operator, and equally the launcher would be the cn skunkworks operator. And then I would build that Docker image in the background as we start to look at the Helm chart. So let's do a Docker build, and I'll tag that with my Docker handle, so cn skunkworks operator latest. And whilst we're doing that, let's look at how do we start to package this up into something we can use. So I would typically have a folder directory called chart or helm, whatever you might like. I'll call it chart. So helm create cn skunkworks operator. And that's because I'm in the local directory, and we have to do a little bit of magic here. Because we're in this directory, Helm is cowardly trying to not do anything. So let's go make directory chart, call that command again. And what we want to do is to take everything inside of that skunkworks operator and to move it here. And then what we can do is to ls on that directory, nothing in there, remove it. And so what you see is we have at the root level a Docker file. We also have our chart for deployment, and we have our code here. And this is a nicely balanced structure. We'll come across in a moment to looking more at that. I've got a quick error in my Docker file because I didn't change the name. So let me modify that, rebuild the Docker file. Typically for convenience, at this point, I would start to look at writing a make file. If you've worked with something like the project for Operator SDK or Kube Builder, this will be pretty familiar territory for you. So Docker build, cn skunkworks latest up, and then Docker push might be another command that we want to add later on. Okay, so let's go ahead and get that going again. So I will do a Docker build again. No cache equals true, because I think I saw a caching error in there. And let's go back to looking at what we're going to do with Helm. So the first thing you get is a confusing double directory because you've got charts inside of there. Those would be the dependencies of your chart. We're going to get rid of those. We have values, we have chart, and then we have templates. And that's all we need. So the first things first is we can delete most of what's in the templates folder. And I'm just going to try and zoom this in a little bit to make it a bit clearer. So tests, for now, we're going to get rid of that. Helpers, we can get rid of those as well. Let's delete those. HPA, so horizontal pod autoscaler, ingress, notes, get rid of all of those. And we come down to deployment. So deployment looks good. Some of the things we're going to need to think about are adding a scrapable endpoint. So we might want to look at how to add the Prometheus metrics endpoint onto this container. And again, just for posterity, I've got a couple of other projects in the same wheelhouse as this. And when we look at how I've structured those, when we looked at the deployment, you'll see that often it's very minimal touch with only maybe one or two alterations. So we're going to come back and we're going to add a metrics endpoint onto here. What else do we need? We've got a service, that's great, and a service account. So from there, we should be able to render this Helm chart just to check that it actually works. So we're going to chart, Helm, template, generate. So the first thing that's happening is that the templater is looking for something that doesn't exist, and that's the service account name. So in service account, line 5, you can see here it's looking for service account name. So include the service account name, and that is because I've done a deletion on the templates that included notes and helpers. So what we can do instead is we can use .values .service account name. And that service account name we can define in our values, and we'll call it cn skunkworks SA. Everything else really in here can be gotten rid of. There's not a great deal that we want out of the default information here. Although that said, we can modify some of these things where necessary to suit our purposes. So you can see here, repository and tag we could keep. So let's update that. So repository is going to be Tibar, which is my repository. CN skunkworks operator. Tag will be latest. I will get rid of a few of those components there that aren't necessary. What else have we got? Service account name, that will also change to value. And we might want to think about how we restructure this. So actually service account name is defined there. So what I'll do is, rather than reinventing the wheel, let's just call service account dot name. So back in here, dot name like that. And we'll do the same thing inside the deployment. Service account dot name. Pod security context as well. We removed that out, but we can always add that back in later on if we need to. Pod annotations, we can leave those blank. So let's have a look what else we need. Cluster IP, we don't need a service, we don't need an ingress. Resources we can leave as is. Auto scaling we can remove completely. So let's have a look where we are right now. So deployment line 27. Let's remove so this is labels. Labels is something that we could leave in with the helper function. Now, this is an interesting one because these are all coming from the helper function that I deleted. What I'll do is, rather than have to reinvent the wheel on everything here, I'll bring in the helm, the helper function again back into it. And again, it is simple as doing a another create. So create, and then I'll just copy out that helper function just here. And the helper function has a bunch of useful stuff. So if I delete that now, we've got service.type inside of service, and for our service here, we'll keep it as a cluster IP. And our service port, we can put on 80 for now, although we don't really have an accessible service for this. And auto scaling enabled, which comes out of our deployment, we can simply turn that off. So that is on line 8 here. So there we get our rendered context. And I've changed more than necessary really there. You could just use this out of the box, but it is nice to know exactly what you've got in there. So we're using the helper functions to give us some of the basic stuff, such as the release name, and in our values is the real minimum we can go with to get this up and running. So let's have a look at our Docker image again. Our Docker image has built, so let's now do a make Docker push. Or was it Docker push or was it Docker build? Let's have a look. So if I go down to our make file, which is something I need to move to the root level. If we look at our make file, we've got a make Docker push there. So I'll probably have to log into Docker here. So if I go Docker login, and with that, I will just make sure that I can push my container. So let's try that again. Okay. Let's do our Docker push. And in the meantime, let's come back to what I was just talking about with making sure that we can scrape our metrics. So rather than having an HTTP endpoint, let's use 8080. And our target port will be metrics. And we'll call this metrics. We'll go down into our deployment and we will change this from 80 to 8080. And that will match the target port of metrics. So now we can successfully see our operator rendering in the template. So I go into chart, helm, template, and that is now rendering out just the way we want it. The liveliness probe we can disable at this point in time because we do not have a liveliness probe endpoint, but we can add one in later on. The Docker image should be pushed by now. And what we can do is give this a go in our cluster. So if you remember, we are connected to our local cluster on kind. So what we'll do is from our folder is we will deploy the Helm chart as a new release. So Helm, so we'll call this CN skunkworks, and the chart will be the dot, the local directory. And let's see what else we need to provide. I think we also need an install, that always helps. So let's see what's happening. So here you can see the CN skunkworks operator has started up within our cluster, and we have effectively now completed that life cycle of building an operator and deploying it. I hope you found this useful today. We've looked at how you've added logs, how you add metrics, how you get started with JaegerTracing, how you build a simple Docker image just from a few lines of code, and then deploy with Helm out to your local cluster, that finished operator. And that operator is now going to be scrapable. It is now going to have metrics endpoints that, with the service monitor in Prometheus, you can pull from the operator the metrics. We can look at sending to Jaeger through adding environmental variables into the operator's YAML template. And we also have logs that can now be collected by Promtail, FluentBit, or some other log aggregation tooling. I hope you've enjoyed this video. I really enjoy making them, and please do like and subscribe. And as ever, if there's anything else that you'd like to see, please let me know, and I'll completely try to guide the content from the community. And again, thanks.